Hello, this is Rich, and today we're going to actually do a tutorial on the C++ scripting. Now, before we get started, I do want to let you know that there has been an update. I will not show you today, but I will explain to you one little thing. A little bit ago, somebody had asked when I showed the original C++ scripting if it would be cool if I could do C# scripting. Well, the good news is about that. C# scripting, C++ CLI, and plain old straight up C++ is supported. So you can program in any language that you want with Snappy. Snappy is a C++ API, and Snappy does not have CLR or CLI enabled. It doesn't. It's pure C++, but you're able to use C#, C++ CLI, or plain C++ scripts. They are all supported. I will do a showing of those to come in another video. But this tutorial here is to show you the actual usage on how to actually access variables, set variables, call functions from scripts. Okay, I'm going to actually show you the usage case here. So what I do is I have a simple test animation, simple window animation test here. But let me run the actual host program here, script testing app, and all it is a simple window. Okay, a simple window that has a border, has close, maximize, minimize button, and it does nothing. That's all. And what this simple window animation script does is it will animate the window's background color. Okay, it'll go from one color to another and then back to the original color. It's just a simple window animation script. So let me show you that. Open Visual Studio. On the second one, we have simple window anim. Let me show you what this script does. From the top here, we have the script API macro. This is defined as declaspec DLL export and extern C. Any variable or function that you want available to the host application for the script system to be able to access needs to be prepended with the script API macro. Okay, so what we have here is we have a global variable of the animation color, okay, the target color, and we initialize it to the color white. We then make a global variable that just stays within the script. It's not exported at all. Okay, it's using the animation system. If you want a tutorial about the animation system, I have another video about that, Snappy tutorial, creating custom animations. So we have an animatable value, color F, okay, and we're going to set the lifetime to 5 and looping to true. Okay, so it's going to be 5 seconds long, and it's going to be looping. All right, then we have the exported render function. So the host will call this function every single frame, and all we're doing is we're getting the main window here, setting the foreground color to whatever the current animation value is of the color animation. Next, we have another exported function, init_anim, and we're returning a bool here. So during the demonstration, I'm going to be showing you how to call functions without parameters, functions with parameters, and functions that return a value to show you how you use the syntax in the script system to do that. So that's why I have a bool here. The bool does nothing. It just returns true automatically, but it's going to be used for the showcasing how to call functions with return values. So what we have here, because this is a test bed here, we have an init_anim, and you would expect the init function to be called once. But the way the host is set up for this tutorial, it gets called every single frame. So we set up some blocking here. Basically make a static bplay, set it to false, and it's going to shoot off this entire section here and then set the bplay to true. Meaning, no matter how many times this function is called in init_anim, this will only be done once because of the static variable. So we have an init_anim function that will initialize the animations. We're going to check if it hasn't been played yet. Have you started playing? If we didn't, we're going to take that color animation, we're going to add a keyframe at time 0, and the color is going to be blue. Then we're going to add another keyframe and put it halfway through the animation at the color we specified. This is the exported color value. And then another keyframe at the end of the animation, 5 seconds, we're going to set it back to blue. So as you're going to see, it's going to interpolate between the blue, the color we choose, and back to blue. And it's going to loop, because we set looping true on the animation. Then I set up the interpolation event to actually do the interpolating of the colors. It's very simple. I just interpolate between the start color and color between the keyframes by a certain percentage. Again, if you want to learn more in depth, you can look at the creating custom animations for Snappy tutorial that I've done in the past. After we're done, we're just going to play the animation. Instead, be played to true. So setting up the animation and playing it only happens once because of this be played static variable. Beautiful. Now at the bottom we have another script API, set Snappy. This is so that our script can actually use the entire Snappy library, and the host will basically automatically set this value for you, so you can just worry about using it, like here. Get application, get Windows, stuff like that. So that's the script. I ran the other application, the actual host application here, and you can see nothing happened. It was just a blue screen. So let me go ahead and show you how to do this. I think you guys would be quite impressed on how I implemented this. So basically, we have the script system, and the script system derives from the Content Manager. Content Manager is an interface that basically allows derived classes to manage content, set their content folders, load content from those folders, etc. So the script system derives from that. So it allows me to load content very easily. So what we're going to do here is going to get Snappy, G_P Snappy. We're going to load a script. Get script system. Now that we have the script system, we're going to load the content. Load content. And we're going to load what script that we need. This is a script system, so we've overloaded the load content function to return the script. Now all we need is a script name. Let's go ahead and show you something really cool. This is the script system, and it's part of the Content Manager. This is why the Content Manager is pretty cool. What we're going to do is we're going to go open the folder here. And we're in the script testing application here, bin64, and we're running debug. As you can see, the content system has its content, iContent Manager uses content in the content folders, okay? And the script system has automatically created a scripts folder to hold the script's content. Inside here, we have our actual script, simple window anim, with our source code and compiled script already inside. Simple window anim.dll is the compiled script, and we also have all the source code for the script in the same file. So you notice where simple window inside the scripts folder we have simple window anim, and then our simple window anim.dll. This is the cool thing. We don't have to worry about specifying a absolute path or relative path to the exe. Since the script system derives from the Content Manager, it now knows where to find the files relative to the scripts folder, because script systems has this content folder set to the scripts. So all we need to do is we need to write the path. In two ways we can do this. One is kind of unsafe, and the other is more safe. I'll do the unsafe here first. It's inside the simple window anim folder. And then it's the simple window anim script. And we can do that. We can load that script here. This is kind of unsafe because we don't exactly know what the operating system's path separator is. So we can do this in a more safe way by using the folder class that I've created. So we have the folder, and we're going to call a static function create path. And it doesn't create a path on the system. What it does is it creates a path string from path parts. So it's a vector, but we can just give it an initializer list, and we'll say that we want simple window anim and simple window anim dot DLL. And here this returns a string. Let's create path here. So what it does is this create path function builds an entire fully qualified path for you. In terms of, it'll add simple window anim and then simple window and um.dll together to make a relative path. It's much safer. This function I made will append your operating system's path separator. Okay. So now we've loaded the script. Well, the script, because it's a part of the iContent manager, it actually returns an iContent. So different things are an iContent. The script class is an iContent. So the load content returns an iContent. In fact, it returns a snappy pointer iContent. And I'll explain the snappy pointers in a second. So since this returns a snappy pointer, we're going to tell it to get the underlying actual pointer, so a raw iContent pointer. And we want to store it in a script. So we'll make a snappy pointer, and we'll make it a snappy pointer of script. And then we need to cast it. I mean, you can do a C-style cast here, but I do prefer to use type safe casting here, so a static cast, and we're going to cast the iContent to a script. So that's what we've done. The load content returns a snappy pointer to an iContent, but really it's the actual script. It's the actual class it's instantiated as a script. So then we tell the snappy pointer to get the raw pointer, and we cast it to the script, and we store it right into a snappy pointer script. Now, let me explain a little bit about snappy pointers. So what snappy pointers do is they're not like the regular pointers you see with like the standard library in Boost, like shared pointer, auto pointer, weak pointer. There's really no relation to that. What snappy pointers do, they don't solve, they're not meant to solve memory leaks. They're actually meant to solve dangling pointers. Because of the nature of Snappy, different systems and different classes will have pointers that are shared. I mean, each system will probably have some sort of pointer to an underlying variable. And if one system deletes it, then all the other pointers are pointing to garbage. And even if your if statements are correct, they'll fail. And you'll end up crashing the program. So you guys should obviously be familiar with dangling pointers. So snappy pointers solve dangling pointer problem. This is done by every time an object, an actual class is destroyed, then the snappy pointer will dispatch, the class will dispatch to all other snappy pointers that are pointing to that object that the object was destroyed, and each snappy pointer will set their internal pointer to null. So this snappy pointers solve dangling pointers. So dangling pointers will not be possible if you use snappy pointers. And now that we've done that, you can use snappy pointers like real pointers. We're going to check. If not the script, then return. Cool. Next, what we're going to do is we have this script here. Now what we're going to do is we're going to I just wanted to mention something. I'm sorry. I just wanted to mention this load content function here. I did pass in a DLL. If the DLL does not exist, then the source code is grabbed, compiled, and then it's loaded. So if you specify a DLL doesn't exist, but the source code for that DLL is available, it's automatically taken care of and compiled for you. If not, if the DLL is actually there, it'll just load it. Okay, just want to let you know that. So what we do here is we're going to call the function setSnappy. So we're going to use the P script, and we're going to use the function call function nr. Now there's two call functions here. We have the call function nr, which stands for no return, and then we have call function r for return, call function return. So call function nr is for calling a function that does not return a value, and calling function r is calling a function that does return a value. We're going to be setting the snappy pointer, which does not return a value. Now let me show you. If if I go to the other script here, let me scroll all the way down. Setting snappy pointer does not return a value, but it does take a snappy pointer in. Now this function will be called automatically for you, so you don't have to worry about it, but for testing purposes, it is not called for this tutorial, just to show you. So we're going to call function nr, and it's very simple. We're going to pass the function name, set snappy, and then we're going to pass the arguments. And this could be as many arguments as your function is. Okay, it's a variadic template. So we're going to pass in G underscore P snappy. We're going to tell it that the snappy that it should be using is this one here. Okay, and then we got to tell it the function prototype in the template, because that cannot be used automatically. So we're going to tell it that it's a void function pointer that takes in a single snappy pointer as it is. This function does not return a value, but the actual snappy pointer set snappy function, but call function nr and call function r do return a value. They return a bool, whether the function call was successful or not. And it has nothing to do with the actual call of set snappy or any function. It's actually whether it could, if there was an actual function at all, or if it could actually call it, if there was some problem calling the function. So we're going to check for that. If we were able to call the set snappy function, or should I say, if we were not able to call the set snappy function, then we should return. Beautiful. We set snappy, so now it knows what we need to do. Next, we're going to actually set the variable in the script. We're going to set that color variable here, way up top here, this color variable to green. We're going to set it to green. So it will go from, let's see here, blue to green to blue. So we're going to check it. Oops. We're going to check it again. If not p script set variable, and we're going to set a variable, very simple, by telling it the variable name, and the variable's name is color. Okay, and then the variable, the data we want to set this variable to will be green. But this takes a reference, so we're going to have to create a variable right here. So we're going to create a color u, color, name it whatever you want, equals color presets green. So then we're going to pass it a reference to our color. So there we go. If it doesn't succeed, we're going to return right away. So now we're going to set the variable. And if it wasn't able to set this variable for some reason, it returns false. So that's why we check. So if we cannot set the color variable to green, then return. Next, we're going to initialize the animations. So we're going to say, if not, p script call function. Now, the init anim actually returns a function, so we're going to call, returns a value, so we're going to call the call function r. Okay, call function return. It's very simple. All we need to do, if you pass in the function we want to call, which is init anim, then we pass it the return value, and we know that it's a bool, so we're going to type in b success. And this doesn't take any sort of arguments. So let's create a function, b success, and set its default value to true. And then we're going to pass it right in. We got to tell it the function signature. It's a bool pointer that doesn't accept any sort of arguments. And that's it. And if we couldn't call the function in an anim, we're going to return, whoops, return. So there we go. We called the function, we told it the function signature, and we pass it the memory address of our bool variable here for the return value. Now we're going to check if not successful, if that anim was not successful, then we're going to return. There's no need to render the animation if we didn't initialize it properly. Then we're going to do one last call, and we're going to just copy this. And this is going to be calling the render function. Calling the render function does not take any parameters, and it does not return a value. So we're going to say that the type is void pointer. Doesn't take any sort of parameters, and it's called render. Call function NR. So there we go. If we're able to call the function render, if we're not able to, return. And that's it. So what we've done here is we've loaded a script by passing it the name of the script here, casting it to the underlying type, which is a script. We checked if it doesn't exist, if the script actually wasn't loaded for some reason or it doesn't exist, return. Then we call the setSnappy function, passing it the Snappy variable. We then set a variable called color with the value of green. We then call another function for init_anim, but it returns a value, so we store that, return value, and be success. We then check if it was successful, and if not, return. And then finally, we're going to actually call render. Now remember, even though we're using init_anim on every frame here, because this function gets called every frame, this only it only happens once, because inside that init_anim function, remember, we made it so that it only gets called once, no matter how many times the function is called. So absolutely beautiful. So what we're going to do now is we're going to run. We're going to run the actual. Oh, let me cancel. Let me cancel. We don't want to load the content every frame, so I'll create a static variable. That way this script is only loaded once. And as you can see, we have a window, and it goes from the blue to the green, back to the blue in a 5-second span. And that's a very simple use case, I should say, for using anims. They're very useful. They can be scripted in real time, as you've seen in my past videos. And I do now support C#, CLI, and obviously C++ here as scripts. And the cool thing is there is no separate steps needed. In what I just showed you in the use case, there's no different steps needed to call CLIs or load CLIs or C#s. Everything is exactly the same workflow. I can't wait to do a video on that soon. But yeah, as you can see. So one more time. And let me show you how this can be done much simpler. That way you don't get confused by the syntax here. I'm going to create a raw script pointer, just so you can see the actual syntax, so you're not getting confused at all. That's it. In fact, we can get rid of this get call here. Actually, no, we can't. Whoops. There we go. We've casted the iContent that was returned from load content into a script. That's it. That's all there was. I don't want you to get confused by the syntax. They're exactly the same, except for snappy pointers. We'll fix dangling pointers. And that's all you got to do. We can call functions right from the script. Set variables. We can also get variables. There's a get variable function. We have two different types of call functions. Oh, just want to let you know, there's also... Sorry, my mic fell. There's also, let me show you some of the functions here. We have the compile function, which will unload the script, compile the script, and reload it. Okay, so if you're doing some real-time stuff and you want to manually detect when you should reload your scripts, you call the compile function whenever you want to, reload because you changed something. That will automatically unload, compile, reload. Okay. Get configuration. All this does here is it passes in whether your script is compiled for release or debug. So this will return release, EC underscore release or EC underscore debug. Enum based on if your script is a release DLL or a debug DLL. Get file is a file class that I created. It returns the file that's associated, which is the simple window DLL file. Okay, you can get various information about that file. Get manager, it returns a snappy pointer of iContent manager, which in this case it actually is underlying a iScript system. So the pscript will return an iScript system. Get name, in this particular case, this will get the name of the script. Particularly, it will return simple window anim. That's it, no.dll. It returns the actual script name, simple window anim. Get platform, this will return an enum based on if it's a 32 or 64-bit DLL. I mean, if you know if it's a 32 or 64-bit script, I mean. So it will return EP underscore x86 or EP underscore x64. Get the type returns the type of content that your scripts is iContent. So it will return the eContent type script because it's a script type of content. Get variable obviously allows you to get a variable. And that's pretty much it here. Thank you guys very much. I hope you enjoyed, and I really hope you like the syntax for using scripts. Before we're set up, you use the script system to call them, but this is much, much easier. Every script is managed by a script class, and you can simply load, unload, reload, compile right from the script. Call, functions, anything you want to do. So I hope you guys enjoy, and give me some feedback. Thank you. Bye.